Okay, let's just do a recap on this week's physics lesson. So we looked at electrostaticity. So before we go into that, let's just look at the structure of an atom, what it's made out of, and then relate it to what we're gonna learn after that. Okay? So we'll start with an atom. An atom is made up of protons, electrons, and neutrons. So an atom, if I were to represent it in a diagram, I would have a nucleus. Okay, and I would have orbital shells around it. So this is the nucleus, and it contains protons and neutrons. And then outside in the shell are electrons. Okay, electrons, as we all know, they are negatively charged, and protons are positively charged. So because protons are in the nucleus and neutron has no charge, the nucleus automatically becomes positively charged. Why? Because it contains proton, which is positively charged, and the shell has electrons, which are negatively charged. Because the electrons are in the shell, they are free moving. Okay, so we call them free moving electrons. And because they are free moving electrons, out of protons, electrons, and neutrons, electrons are the only ones that can be transferred out of or be received into. Okay? So electrons are the only ones that are mobile. The rest, they get stuck there. The protons and the neutrons, they stay. The electrons are the only ones that are able to be donated or to be received. Okay? Keep that in mind, electrons. And why? Is because they are free moving. They are on the orbital shell, number one, and number two, between the proton, electron, and neutron, electron is the most lightest in terms of weight. So because it's very light, it is able to move easily. It gets donated and it gets accepted. Okay? So, let's say we have an object. Okay, let's say we have a cloth. Okay? And then I have a rod, a metal rod. And I want to take this cloth and rub it against the rod. So let's say this cloth at the start, it's neutral. Neutral means the positive and the negative are equal. If 3 protons means 3 electrons. And let's say the rod is also neutral. 4 protons and 4 electrons. 3 protons, 3 electrons. So now I'm going to rub this cloth against the rod. Okay, I'm holding it in one hand, taking the cloth and rubbing the rod. Remember, only electrons move. So the protons are going to stay, the electrons are going to jump to the rod. So when these electrons, they jump to the rod, now the cloth only has protons, and protons are positively charged, and because there's only protons left, this cloth becomes positively charged. Okay, it becomes charged and it's positive. Why? Because only protons. Then let's look at the rod. The rod has protons and electrons, but now there are more electrons here because the electrons have jumped from the cloth to here. So now because there are more electrons than the number of protons, that means there is more negative charge than positive charge. So the rod now becomes negatively charged. Okay, so the cloth and the rod, initially they were both neutral because they had the same number of protons and electrons. But now after rubbing the cloth onto the rod, the electrons jump to the rod. Remember, the protons don't jump, only the electrons can move. Why? Because they are free moving and they are the lightest. So they jump here, so now there are no more electrons here, only protons left, and protons are positively charged, so the cloth becomes positively charged. Whereas the rod, because the rod has received the electrons and there are more electrons than protons, the rod is now negatively charged. So the cloth has donated the electrons and the rod has received the electrons. So this becomes positively charged and this becomes negatively charged. Okay, and then as we all know from primary, positive and positive will repel. Negative and positive will attract. So like charges repel and opposite charges attract. So that's another thing that we need to keep in mind. Okay, then another thing we want to look at is conductors and insulators. Okay, just like heat conductors, we also have electrical conductors. So electrical conductors conduct electricity, and insulators are materials that do not conduct electricity. Okay, such as wood, rubber, plastic, they cannot conduct electricity. But metals such as copper, silver, all these metals, they conduct electricity. That's why our electrical appliances, okay, the elements inside of it are made of metals, because metals can conduct electricity, whereas wood and plastic and rubber cannot. So for example, all your wires at home, okay, let's say they are made up of copper wire. Now, if you realize, they will all be insulated with plastic. So when you see wires around your house, you don't see the wire like that. You see a covering. The wire is inside the covering. So the covering is made of plastic. Why? Because if you want to touch the wire, you won't get electrocuted. But the metal inside the wire, copper, that conducts electricity. Why? They wrap the copper with plastic so that when we handle cables and wires, we don't get electrocuted. So plastic is an insulator of electricity, and copper conducts electricity. Okay? So, and then we look at a small part of the dangers of electrostatic phenomena. Okay? So electrostatic is basically the movement of electrons, okay, and how it affects us on Earth. Okay? So now, lightning. Okay, lightning, as we all know, is dangerous. Why? Because there are a lot of electrons running down from the cloud and reaching the Earth. So when the electrons escape from the clouds and they are reaching the ground, we see it as lightning, because there's so many electrons trying to reach the ground, reach the Earth. So you see it as lightning. So when there's too many electrons, there's too many transfer of electrons, then it can be dangerous. Normal, minimal amount of electricity, electrons jumping around is fine. But when there's an enormous amount of electrons passing by, it can be dangerous. Okay? So that is why buildings, high-rise buildings, they have a rod at the top of the building that catches the lightning. It catches the lightning, there's a pipe running down, and then it goes straight to the ground. So when electricity hits the top of the building, because the electricity will hit the tallest part of the building first. So when it hits the tallest part of the building, there is a pipe that will carry the electrons down and channel it down to Earth. So people in the building, appliances in the building will not get affected. So they build this pipe that will run down straight to the Earth. So lightning strikes, and then the electrons pass down the wire and it goes straight down to the Earth. And once it goes down to the Earth, it's safe already. Okay? So that is all for this week's recap.